All right, so a couple more things in 6.2 that I wanted to go over. Let's say you get a solution that looks like this. y1 is 1, y2 looks like a function that you should be familiar with. Okay. So say it winds up being something like this, where you have this look to the solution. And number one, you have to write it. What functions do they look like? Well, y1 is easy. That's just 1. That's not going to change. But if you know e to the x as a power series, which you could go into the book and go to 6.2 or 6.1, and they'll give you a whole list. And e to the x is going to look like 1 plus x squared over 2 factorial plus x cubed over 3 factorial, and that continues on forever. Well, pretty much it's exactly the same except for that 1, right? So what I'm going to say is y2 is going to equal negative 1 plus e to the x, and then you would wind up getting this portion here because that negative 1 and the 1 would cancel out. So now when you write the solution, right, say you're writing the solution where it looks like y equals c1 y1 plus c2 y2. Now you have functions that you could put in there where it's going to be just c1 plus c2 negative 1 plus e to the x. All right, so that hopefully that helps on a couple questions on the homework. But remember, when you're doing these problems, they take a little while, so we'll see how it goes. Now, a couple things in this homework set 6.2 that are pretty straightforward and not too bad. You don't have to do much because they say without solving, they want you to find the minimum. Can't spell. Radius of convergence. R, right, for the power series we just get the right wording, right, of the power series about that. So they do two things. They say about the ordinary point x equals 0 and about the ordinary point x equals 1. All right, so when you do this, right, so say you get a differential, and I don't know, let's do x squared minus 16 y double prime plus 2x y prime plus plus y equals 0. And then what you really want to do is you're just taking this first term and taking that function in front of the second derivative or whatever that leading order is, and you're just setting that to 0 and solving. So here I'll get plus or minus 4, right? So for the first part where it's centered, or it's about the ordinary point 0, I know that the distance, right, the distance between 0 and plus or minus 4 is equal to 4. So your radius of convergence is going to be 4 about the ordinary point x equals 0. Okay? But for the point at x equals 1, right, just what's the distance? What is the distance between, 1 and 4, right? So if you want to do distance formula, that's fine, right? We know that's going to be 4 minus 1 squared. We all know that's going to be 3. And what about between between 1 and negative 4? So the distance there, right, if you're doing this, you'll have negative 4 minus 1 squared, which we know will wind up being 5, right, because you'll get 25. So the minimum radius of convergence will be 3. So R will be 3 about the ordinary x equals 1. So for at x equals 1, it's going to be 3, and for x equals 4, it's going to, x equals 0, it's going to be 4. All right, so that should help you with 6.2. As we go along, I might do another example for 6.2 of the last video, the harder video that we had.